Right, welcome back to my organic chemistry class. So let me quickly explain what is meant by optical isomers. So we've looked at geometric isomers, but now we need to check optical stereoisomers. So optical isomers, they are often like this. All right, so take for an instance, you have a carbon, and this carbon is attached to 4 different substituents. Like, let's say we have H, we have CH3, we have OH, and we have let's say we have like bromine or something. So you realize that the 4 groups that are attached to this C, they are different. Hydrogen, methyl group, hydroxyl group, the halide. You can see that the 4 groups are different. Now, this kind of carbon is called a chiral carbon, a carbon that is attached to 4 different organic groups. 4 different homologous series are attached to this carbon. So because of that, if you look at this carbon in the mirror, the image you are going to get is going to be laterally inverted, obviously. So the CH3 is going to be somewhere here. The hydrogen will be somewhere here. Then your OH will still be somewhere here. And your CH3 is going to be, your bromine rather, is going to be somewhere here. Now, this one over here is called the D isomer, while this one over here is called the L isomer. This D means dextro-rotatory. I'm sorry, I'm kind of rushing and it's actually not very convenient. So dextro-rotatory, while the L is called level rotatory. But what do you really need to know about this is that this guy and its mirror image, because this is what you see in the mirror, this is the original stuff. This guy and his mirror image cannot be superimposable. It's like when you hold out your left hand. I have to go back to this. Let's say you are holding out a hand. Like this, and let's say this is your right hand, like this. You're holding your right hand like this. I look at it in the mirror. What you're actually going to have in the mirror is going to be a laterally inverted picture or image, right? That will look like this. Let me use this. Let me see. Can I really rotate it? Okay, no worries. I'll just edit it. Like that. No. Okay, let me just edit so that you see what will happen. So this guy will come to this side instead, and this guy will become small like this. You hear my point? So if you look at your hand in the mirror, it's going to look like this. This side will swap side with this, and this side will swap side with this. So that mirror reflection is what actually brought about what we call the optical isomerism. So it only occurs when we have a chiral carbon atom. That is a carbon atom that is attached to different groups. So this one is attached to hydrogen, methyl group, hydroxyl group, and the halide group. So because of that, it's attached to 4 different groups. So by the time you look at the mirror image, you get an exceptionally different something from this. Are you getting me? So no matter how you rotate this guy, it will never match this guy precisely. For instance, if you rotate it like this, and the CH comes here, the BR will be at the middle, the OH will go here. So in a way or the other, by the time you try to rotate it, you can't impose this guy on this guy. You can't place the two on top of each other and have a perfect result. No, 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 no. So because of that, we call them optical isomers, such that a particular compound cannot be superimposable on its mirror image. Are you getting me? And this optical isomerism actually helps us in some instances. It helps us, especially in structure like in carbohydrates. We are still going to do all those ones later in the future, where we realize that okay, I think the L isomer is actually very good for the health, that and that, this and this, and so on and so forth. So, but majorly what you are meant to know is that when you have, excuse me, when you have a particular compound whose carbon is attached to 4 different groups, then it is definitely going to be able to undergo this optical isomerism. So like this carbon now, and that carbon that is attached to 4 different groups is called a chiral carbon. So let me quickly write that for you. So a chiral carbon, a carbon attached to 4 different groups. So this carbon here is a chiral carbon attached to hydrogen, bromine, hydroxyl, and methyl. So it's capable of undergoing what we call the optical, the optical isomerism. So that's what you need to know about that.